Hey guys, today we're going to take some notes on multiplying decimals. I apologize I don't have a picture to show you. I got so excited I wrote my notes and didn't take a picture before I filled them all in. So here we go. We're actually covering two lessons, Lesson 3-3 and Lesson 3-4, and both of them talk about multiplying with decimals. So the only difference is in the first lesson only, so I'm just going to say multiplying decimals. The first lesson covered multiplying a decimal and a whole number, and the second lesson covered decimals by decimal. So the bottom line is the directions are the same for both. And we're going to probably practice the tougher problems. Oops, yeah, we're on the 12th. So today's date is 9/12/19. So what we're going to do is go through some steps, and then we have some just number examples, and then you guys glued into your composition notebooks 2 word problems. So we'll get into that in a little bit, okay? All right, so let's get started. So let's talk about some steps. So number 1, we're going to estimate first. So what we did practicing in our notes from yesterday was estimating products. And again, it's actually even more important to do estimation with multiplication than it is with adding and subtracting, because it's real. The most common mistake is to misplace your decimal point. So this will help you eliminate that. So estimate first, and this helps with decimal placement. I think I had that in our notes from yesterday as well. And I'm going to highlight this. Okay. Step 2, this is where we just get into the process. So when we are multiplying decimals, we actually pretend there are no decimals. We don't need to line them up. In fact, people do that. They add a bunch of zeros and then they get lost. So forget all of that. Pretend temporarily there's no decimals in your values. So you're going to multiply as if the decimals don't exist. Okay, it's going to be a piece of cake if you keep that in mind. Now, this is the weird one, and it's going to sound, it's a little cumbersome to write, so for me, so I'm hoping the words come out good for you. Now we have to put the decimal back into the answer. So we're going to look back at those original numbers that had the decimals in, and we're going to do some counting. What are we going to count? We're going to count how many digits. Count how many digits come after the decimal in each original number. Now, you may only have one number that has a decimal. Both of them may. It just depends. So you're going to count up in total all the digits that came after decimal points in your original values. Okay? And whatever number you get here in that step 3, that's going to be helping you place your decimal in your answer. So your answer, or your product, needs the same number of digits, after the decimal as you counted in step 3. Okay, so if you counted altogether 3 digits after the decimal, then your answer has to have 3 digits. But what if the number you got, and you count from the end of your number backwards the number of spaces that you thought you had digits after the decimal point, and you run out of digits? What do you do in that situation? Okay, well, I'm here to tell you. So if there aren't enough if there are not enough digits in your decimal, or in your number, so if there aren't enough digits in your number to place the decimal in its correct position, annex zeros. Remember we talked about that word? That means to add. But here's the funny part. We're going to annex zeros in the front of the value, or of the number, until the value, or until the number is the length it needs to be. So again, needs to be. That length is determined by how many digits need to come after the decimal point. Now, we've been talking all along about this whole idea of estimation, and how that helps is for us when we are checking for reasonableness. Okay, so check for reasonableness. And what we're looking for is the estimate approximately the same as the actual number? You know, same number of digits, same value as similar to the value you had in your estimate. Okay? All right, so let's get to the practice. So I'm going to go on to my next screen. So if you need to pause to copy stuff down, go ahead and do that, and then join back up. All right, so the directions are going to say multiply. So we're going to have a variety of problems, some with two values that have decimals, some that just have one. So we're going to start with a simpler one. So we have 8 times 4.47. So here's what I do. I'm going to start by counting how many digits came after the decimal point in each of these numbers, because I'm going to use that value later. So 8 had no digits after the decimal point, but you can see there's 2 digits after the decimal point and 4.47. So what this tells me when I add that together, oops, I forgot my number. We're going to get 2 digits after the decimal point. Okay, so that I'm going to use later. All right, so now let's do our estimation. So we have 8. 4 is not big enough to round 4 up, so it stays 4. So that tells us we're approximately at 32. So we're looking for a 2-digit number somewhere in the 30s. All right, so now I'm going to get back to the problem at hand. So I'm going to take my 2 numbers. I'm going to forget there's any decimal points, put the shorter number on the bottom and the longer number on top. The shorter number determines how many rounds of multiplication you do. So if you put the shorter number on the bottom, you have less math to do. So 8 times 7 is 56. 8 times 4 is 32. 32 plus 5 is 37. And 8 times 4 is 32. 32 plus 2 is 35. But now is where we get the idea of the 2 digits to come in. So we start at the back of the number and we move the decimal point left twice. Okay, so we get an answer of 35 and 76 hundredths. Now, is that number 2 digits in front of the decimal point? Yes. Is it around 32? Yes. So what we're saying is there is a connection between our estimate and our actual. So I'm just going to box that and be done. Okay, let's try another one. By the way, you might hear my phone ping. My niece is being induced in labor, and we're hoping for a baby tonight. So, yay! So exciting. So our next number is a teeny number. It's 36 ten-thousandths. So 0036 after the decimal point, and then we're going to multiply by 19. Okay? So what I'm going to do is start by counting how many digits I should have after the decimal point of my answer. So the first guy, wow, 4. We have 4 digits after the decimal point. That's a terrible 4. Sorry about that. 4 digits after the decimal point. 19 has 0 digits after the decimal point. So altogether, I'm going to have 4 digits come after the decimal point in my answer. Okay? Now here's the weird thing. Let's do our estimation. Well, guess what? When I try to round the first number, it's so teeny, it's closest to 0. And then we multiply it by 19, and we should get an answer close to 0. Now, you're saying, then that doesn't make sense. How can I multiply and get nothing? Well, you're not going to get nothing. What you're going to get is something that's less than 1. Okay, so let's go ahead and do the math. So I'm going to drop all those zeros in the decimal point, and I'm just going to have 36 times 19. So here we go. 9 times 6 is 54. 9 times 3 is 27. 27 plus 5 is 32. Put in a placeholder. 1 times 6 is 6. 1 times 3 is 3. Add up, and I get 4, 8. Oops, almost multiplied those. Yep, 6. Common mistake. I swear I make them the same myself, right, guys? So don't ever feel ashamed if you do something like that. It's just a learning process. So now we're going to go, and we're going to put the 4 digits in. So we start here, we move it 1, 2, 3, and I have to go one more. So notice I have this big old blank spot. That's where I put in a 0, okay? So what I got for an answer was 684 10,000ths. So I've got 4 digits after the decimal point, so I'm good with that. It's a number that's around 0, and it's for sure less than 1. So I'm confident that it matches my estimation. So I'm going to say, yep, that's the answer. Okay? Now, by the way, there are times where I do calculation errors in the notes, and I apologize profusely for it. If you catch me make a boo-boo, let me know, okay? And in class, we'll make sure we correct it. Never write incorrect things if you can avoid it. So we have 1,400 thousandths times 3 and 7/10. So let's count up what we got. Let's see, I see 3 digits here, plus 1 digit here after the decimal point for, again, a total of 4 digits. Okay, let's go ahead and estimate. And what you should notice, first number would round to 0 again. Second number would round to 4. I'm still getting an answer that's 0, which means I'm looking for a value at the end that's less than 1. Okay, let's do the math. So basically I have 14 times 37. And if you want to do 37 on top, that's okay. Okay, so we get 7 times 4 is 28. 7 times 1 is 7 plus 2 is 9. Put in a placeholder. 3 times 4 is 12. Cancel that one out. 3 times 1 is 3 plus 1 is 4. I'm going to add up. 8, 11, 5. And now I'm going to go ahead and take what I counted here and apply it to my answer. Decimal point, I move it 1, 2, 3, 4 places to the left. Again, I have a blank spot. That's where I fill in that 0. So my answer is 518 10,000ths. So I look at that and I say, yep, I've got 4 digits after the decimal point, so I feel good about that. It's definitely less than 1, so I'm going to say my estimate concurs with that answer. So I box it up. Okay. And then I have one more, and then we'll do the word problems. So I get 0.26 2600ths times 0.205 or 205 thousandths. So again, I'm going to start by counting how many digits came after the decimal point. This one had 2. The second value had 3. for a total of, wow, 5 digits. Let's do that estimation. Let's see. The first guy would still round to 0. The second guy would round to 0. So I'm getting an answer close to 0. So again, I'm going to get something that's less than 1. Oh, that's a terrible looking. Looks like one big, huge, long word, doesn't it? Sorry about that. Less than 1. So let's go ahead and do the math. Now again, I'm going to choose to put the longer value on the top, the shorter value on the bottom, because then that's going to save me rounds of multiplication to do. So 6 times 5 is 30. 6 times 0 is 0 plus 3 is 3. I'm going to cross them out. 6 times 2 is 12. Put in a placeholder. 2 times 5 is 10. 2 times 0 is 0 plus 1 is 1. And 2 times 2 is 4. Add up. And I get 5330. But now I got to apply how many digits come after the decimal point. 5. So I start at the back, move 1, 2, 3, 4, 5 places to the left. Fill up that blank with a 0. And I get 5,330, and it looks like tens, hundreds, thousands, 10,000, 100,000s. Whoa, that's big. So I have 5 digits after the decimal point. Definitely it's less than 1. So I concur that my answer, barring any kind of calculation error, looks good, and I box it up. Okay? All right, so let's do some word problems. Okay, so just like yesterday, we had some word problems, very similar kind of word problems. We've got a certain car can travel 28.45 miles or 28 and 45 hundredths miles with 1 gallon of gasoline. The gasoline tank can hold 11.5 gallons. How many miles can this car travel on a full tank of gas? Justify your answer. So when they say justify, they're basically provide numerical evidence that you were able to do it. So I'm just going to highlight a couple things. I'm looking at the question, and I'm looking at what they want the answer to be in. So I know my answer has to have a label of miles, so that's going to help me. They also tell me here that they were traveling on a, oh, that's really big. Let's, I don't like that one. Let's do over here. A full tank of gas. So that's right here. They tell me in the beginning a couple of pieces of information. They talk about it can travel 28.45 miles with 1 gallon. And then we're told another key piece of information that there's the tank can hold 11.5 gallons. So basically, we have these 2 pieces of information here. We have 28.45 miles is what I can get with 1 tank, or 1 gallon, excuse me. And then the tank, oh, that's a terrible color, sorry. Let me make that darker. One tank, and that's going to be 11.5 gallons. Okay, so I want to write an equation so that miles will be on top, and I'm going to get rid of the gallons. So here's what we're going to do. We're going to take that first key piece of information, 28.45 miles, and we're going to write it as a fraction per 1 gallon. And then we're going to take the other guy. We want to get rid of the gallons. So we're going to have 11.5 gallons over 1 tank. Okay. So if I multiply, then I can cancel out the labels. If it's the same label top and bottom, I can cancel them out. So I'm going to go over to the right here and do the calculations. So I'm going to just disregard I have decimals. And look at this monster problem they make us do. Okay, so before I do this, I'm going to estimate my values because I'm a little worried here. So let's see. 28.45 is going to be about 30. 11.5 is going to be about 12. So I know that 3 times 12 is 36, and then there's a 0. So I know my answer is going to be somewhere in the 300s. Okay, so let's go ahead and do that math. And then let's see, how many digits do we have coming after? So let's see over here. We've got 2 digits and 1 digit for a total of 3 digits after the decimal point. Okay, so now I get to do math. I'm so eager to do the calculations. So I get 25. I get 20 and 2 is 22. I get 40 and 2 is 42. And I get 10 and 4 is 14. Put in a placeholder. Oh, I love multiplying by ones. 5, 4, 8, 2. 2 placeholders, because I got to get to the hundreds, the same numbers. 5, 4, 8, 2. Add up, and I get a 5, 7, 11. I get 12, 13, 17, 10, 11, 12, 3. Now, remember, we have the 3 digits after the decimal point, so we're going to take this guy and apply him here. 1, 2, 3. So I get 327.175. I've got 3 digits in front of the decimal point. It's in the 300s. I feel pretty good. And the reason why my estimate was so much larger is because I rounded up both of the numbers. So that actually makes a lot of sense. So I'm going to write the answer as a sentence. Let's see, this car can travel 327.175 miles per, and I'm going to say tank of gas. Now, some people would say, well, maybe we should just say 127. Didn't ask us to round, so we're just going to leave the answer as is. Okay, let's try the next one, last one. We've got a batch of trail mix, calls for 1.2 pounds of dry cereal. So I'm just going to highlight some stuff as we go through. Piece of information. This gal is making 5 batches. So I'm going to go ahead and circle that up. She already has 22 pounds of the cereal. How many more pounds of dry cereal does she make? So now also with the beginning, it's dealing with a batch. So we have 1 batch, and that's going to be equal, we need 1.2 pounds. That's abbreviation for the cereal, for her trail mix. We've got a fact that she wants to do 5 batches, okay? So let's write that down, 5 batches. Okay. So let's see, how are we going to do this? We want to figure out how much cereal she needs altogether. So we need to get the pounds of cereal to be on top. Because right here, it says how many, oops, sorry, wrong thing. There we go. How many more pounds of dry cereal. So that's got to go on the top. Okay, so this orangey guy, I'm going to go a little darker. So I get 1.2 pounds of cereal over 1 batch. And then I can multiply it by 5 batches. And then I can give it a denominator of 1. So this is going to be my multiplication problem. Now, I have 1 digit after the decimal point in the first guy, none in the second guy, so I'm going to get 1 digit after the decimal. So I'm going to go ahead and estimate here. My number is about 1 times 5. So I'm going to get somewhere in the neighborhood of 5. Okay, so now I'm going to go ahead and work on this. And my actual calculation is going to be 12 times 5. Remember, no decimals as we're doing this. So, wow, that was easy. Math fact, 60. Okay, but remember there's got to be one digit after the decimal point. So we move over, and we get 6.0. Now, that to me is reasonable with the 5, because remember I round down from 1.2 to 1. So I feel good about that. But that's not the answer. That's how many pounds of cereal she would need for 5 batches. Okay, but guess what? She already has some. So we're going to take this answer, and we're going to subtract the amount she already had, which was the 2.2 pounds. So now we're doing something from 2 days ago. So bring the decimal point down, rename. 10 take away 2 is 8. 5 take away 2 is 3. So this answer is the final one. So Nigella, or is it Nigella? I think it's Nigella. Needs 3.8 more pounds of cereal, to make her 5 batches. Okay, and that's it. Now, I know this was a long video, but guess what, guys? I decided I'm not going to give you another one for the week. Yay! So, because you guys have done a lot of word problem practice through the last couple of notes. So I think you're ready to do some word problems, and we'll talk about it and work on it together in class. All right, have a great night.